Okay, so now we're going to derive the multiplier effect. So remember, the multiplier effect is graphically, the multiplier effect says that if we have real GDP, aggregate expenditures, our 45-degree line, okay, that if we've got an aggregate expenditure curve, okay, which equals C plus I plus G plus NX, okay, and I, G, and NX are autonomous, and of course this is consumption, which has autonomous consumption built into it, that if we get an increase, say in government spending, this line shifts up parallel to itself, okay, shifts up parallel to itself by exactly the amount of government spending that has been injected, okay? But you can see that this gap here, that increase in government spending, led to a far greater increase in GDP, and vice versa as well. And we explained how that worked. It's simply because any injection into the economy then filters through consumption multiple times, okay, based upon the marginal propensity to consume. And that's the key. So let's derive the multiplier mathematically, okay? So we have, we'll start with our very basic expenditure model, which is C plus I plus G plus NX, okay? And let's then break down C. So let's replace C with the consumption function, C0 plus MPC times Y plus I, and I'm going to make these autonomous, plus G plus NX, okay? You'll notice I have Y on both sides of the equation. So let's solve for Y by subtracting MPC times Y from each side. So we have Y minus MPC times Y equals C0 plus MPC times Y plus I0 plus G0 plus NX0 minus MPC times Y. Okay, so all I do is subtract MPC times Y from each side. It's a perfectly legal algebraic manipulation. You'll notice that on this side then, plus MPC times Y minus MPC times Y equals 0. So those two terms go away. What are we left with? Y minus MPC times Y equals C0 plus I0 plus G0 plus NX0. Now, this Y has been distributed, so what I'm going to do is undistribute it, okay? What does that end up being? Y times 1 minus MPC equals C0 plus I0 plus G0 plus NX0. Okay, you'll notice that this term here is the same as this. Okay, if you, that Y times 1 minus MPC equals Y minus MPC times Y. Now what we're going to do is we're going to isolate GDP. Okay, so this ends up being, and we do that by dividing through by 1 minus MPC. What do we get? We get Y, let me move this over. We get Y times 1 minus MPC divided by 1 minus MPC equals 1 over 1 minus MPC times C0 plus I0 plus G0 plus NX0. Okay, now these two terms obviously equal 1. Okay, 1 minus MPC divided by 1 minus MPC equals 1. So then what are we left with? Y equals 1 over 1 minus MPC times C0 plus I0 plus G0 plus NX0. Okay? This term here, that is our multiplier. So let's assume margin of propensity to consume is 0.8. Then this equals 1 over 1 minus 0.8, which equals 1 over 0.2, which equals 5. What does this mean? If I increase, for instance, exports by $100 million, GDP will increase by 5 times that, $500 million. If I decrease government spending by $1 billion, GDP will decrease by 5 times that, or $5 billion. Okay? This is the multiplier. If people instead are saving 90% of their income, okay, consuming 90% of their income, in other words, MPC equals, say, 0.9, what do we get? 1 over 1 minus MPC equals 1 over 1 minus 0.9, which equals 1 over 0.1, which equals 10. In other words, if investment falls by $10 billion, GDP will fall by 10 times that amount, or $100 billion. If government spending increases by $5 billion, GDP will increase by 10 times that, or $50 billion. This is the multiplier. Again, in the last video showed how that initial change in some autonomous expenditure resulted in multiple changes in GDP, and the multiplier effect is adding all those multiple changes up. That's your ultimate change in GDP. How do we know how much, if we were to add all that process up until consumption went to 0, how much would GDP change overall? Whatever the change is in your autonomous expenditure times the multiplier. That's how much GDP changes overall.